There we go. We are ready for a new stream. What's going on today? Well, nothing that hasn't already happened. Measure optimizer. Let's get started. What I'm gonna be working in this stream is the measure optimization. So if we try to run this, let's get right into running it, and it doesn't work. Okay, no problem. I guess I was messing around the code, and what's wrong? Oh yeah, of course. This should be an enum. I can easily do the casting, or even simpler, I can just comment it out. So that was the first attempt on getting something to work. But to be honest, I'm gonna start all over again and rethink the whole meshing algorithm, because right now it really isn't an algorithm. I mean, technically it is an algorithm because it's a steps. It's a finite number of instructions that actually do the job. But the result is it's still better than what it was at the beginning. But what is happening anyway? Something is not working as expected. Okay, simpler measure. What did you do? So the simple measure isn't working anymore. Data blocks. Yeah, that seems... Huh, that's interesting. I'm gonna quickly check whether I have messed anything in the source. Maybe I left something a bit in a dirty state. The only thing that I've changed is the block, and I've added an enum. Then the new, okay, I was messing around with the wrong function. So that's the measure, but not, okay, my bad, my bad. So I started touching this function, which I shouldn't have done it. Where did it go? It's a blocks generation. So yeah, okay. I was trying to be a little bit smarter here. So this function, what does it do is it generates a bunch of blocks, which is the foundational data upon which the measure will work on. So the chunk data is nothing but a size of a chunk, the sector in which it will be spawned, and a vector of blocks, which is laid in memory like this. So this is going to be a chunk. That's the worst cube ever made by humanity. But this is nothing but a chunk, and inside we're gonna have multiple blocks, and each block is gonna be like this, a little bit better than this guy here, and they will have a sector inside. No, they will have a coordinate, which again This is like the coordinate thing is so important that I'm gonna make it every stream. So our coordinate system goes like this. This is plus x. This is y. No, that's not y. Let's see. That's why I need a memo every time, because this is minus z and this is y, positive y. So this is our coordinate system. And what this generates is metadata that's it's kind of a point cloud, but more like a cube cloud. So it defines through a function which of these blocks is of which type. And the basic type is air. So if the block is not air, then it's going to be ground. So for now, I'm just supporting two types of blocks, which is air, invisible, and dirt. The function is pretty simple. Right now, I'm just using a combination of a cosine and sine to generate a hill-like terrain, which is going to be, if you can imagine, one dimension going like that, and the other dimension, ooh, that's the worst arrow ever, and the other dimension is also going up and down, and then what they do is that they create this very how do I even define it? It's very hilly terrain, and this makes up something that is a bit nicer to see than just a simple flat terrain. And I always forget that on the stream it would be better if I zoom in the IDE. I don't want to exaggerate too much, because then it's going to be harder for me to write code. But I think 150 is enough. So back to the code. This function generates the baseline for the terrain, and then this test is going to assign dirt to everything that is below that line. So imagine having a stack and then a function that is across the whole, like the whole world, and everything that is below the function is going to be considered terrain. And this is valid for every cell in the world. And unlike other games, this is made of cubic blocks. So instead of having like a big long chunk of blocks, I think it's easier. Well, it's easier, at least in theory, to have smaller blocks, because the one underneath might even not be visible. And it just gives me a little bit more control, and also 32 by 32 is nice for doing bit magic. So I'm gonna keep it like this for now. If I change mind, then we always have time to change things around. And okay, that being said, here is where the first optimization stage happens. So in this block of code, this is checking whether the current block is surrounded by, well, first of all, you can see here there is a -1 and a +1. So this vector generates an envelope in which the blocks are also generated outside of this function. And the same happens all over the sector, and this allows me to reason afterward what to do with this block, so I know what the neighboring blocks will be as well. And also it avoids me to do bounds checking, because I always know that within the inner block, I can check one block in every direction without incurring in bounds, out of bounds errors. So this first check just does that, and it's going to check the upper, and what is this? This is down, and then this is front, back, right, and left. It's going to check for all 6 of the sides surrounding the block, and whether it is surrounded by air in any of these directions. And then we're doing some logic. So this is the simplest logic, and which says that if the block is surrounded by air, well, if any of the faces are in contact with air, then we want the block to be visible. No, yeah, and in the other case, that means that the block is very deep into the ground, and it's only surrounded by well, for now it's just binary, so if it's not air, it's going to be ground. So if the block is all surrounded by ground types, then we don't want to draw that, because we're going to be on top of the ground anyway, and we don't want that to render whatsoever. So we're just ignoring that. So this, uncommenting this, should bring us back to what we were at the beginning. So I'm going to ignore the new check that I was trying to do, and this really works on bit mask magic. So instead of checking manually and doing this big R at the end, I want to preserve the mask that I will also be using to check every face afterwards. Because the next stage, given that we have chosen this path, is going to be converting this like block space into actual meshes. And this is where the meshing really happens. And the first stage of the meshing is to generate the vertices. And then after the vertices have been generated, like for every cube, we're going to have 1, 2, like no, for every chunk we're gonna have let's say this is a 3 by 3, and we will have 1, 2, 3, and 4 vertices. So at the end we're gonna have 4 times 4 vertices, and this is exactly what happens here, that we're gonna add one index for the last vertex. And once we have that, we can just make a big block and work on addressing. This is just all about memory offset. Don't really need to explain much about it, but the cube will be addressed with letters which are each relative to the current position of the block that we are looking into. This is going to be A, this is B, C, D, this is E, F, G, and H. By the way, the last time I also wanted to change the mouse settings and have the cursor a little bigger, which should make it a little bit more visible. Is this a big? Ooh, that's too big. Okay, that was too big. It didn't update it right away, but I feel like this is better for the stream. It's kind of weird for me, but it's a bit fun. Okay, so we get that, and I hope this deserves. Hello, Sami Zaik. How are you doing? We're having lots of fun here. Can see clearly. Nice. Some people will watch it on a portable device, so I'm trying to kind of match different devices, but overall Okay. So what's the next stage? Yeah, we defined the different faces again. This is one polygon, and then this is the second polygon. Everything is triangles in graphics, 3D graphics. So this is gonna say A, E, H. A, E, H. This should be H. A, E, H. That's the first triangle, and then there's A, H, D. AHD, and this is a second triangle. They need to be drawn in clockwise, otherwise they'll be called, because if you look at it from the front, then everything is fine. If you look at it from the back, then you should not see this face at all. That's why the winding is very important, because everything that to know if a triangle, if a polygon is back or from it's being looked from the front or from the back. The graphics engine just looks at the winding, so the order at which the triangle have been submitted. If this is 0, 1, and 2, then this means that we are going clockwise, and this is a front. And if you draw it backwards, which is 0, 1, and 2, this is still, now wait, I messed things up. What happened? Did my phone die? Feel like, no, it didn't die. Oops. It might be back. So I'm using my phone as a webcam. And I'm back. Okay, cool. So there, thanks for doing great. Thanks, mate. You also doing something related to programming? Join me on Discord so we can chat about cool stuff about 3D programming. Okay, so let me just finish this thought. So this is 2, this is 0, because the 90-degree angles was supposed to be 0. And so now we have 0, 1, 2. 0, 1, 2 is going counterclockwise. So this is clockwise, and this is counterclockwise. My handwriting, my mouse writing is really bad. Sorry about that. And that. So that was just a very quick digression about that. And cool. So easy peasy. The rest of the faces are quite easy to know. And now if I try again, it should run as expected, unless I did something dumb somewhere else, and I hope not. Need to go a little bit faster this time. Okay, so the generation is done. This is the current terrain. As you can see, it's made of hills, and they are repeating because of the sine wave. And you can see, if I'm able to draw, okay, I should be able to draw like that. You can clearly see the function going on here. So this is the sine wave, right? And also on the other side, the sine wave is doing like this, and it's just a quick, cool way of getting something interesting without spending too much time on it. So that being said, by the way, the chunk loader, it works great, so we can navigate the world. It's going to load new chunks, and everything is based on this function. So it's not stored anywhere, and it's being generated on the fly. But it's a pretty basic function, so don't expect anything fancy. And the flickering, I've explained it this morning on the morning stream. It's because there is something weird going on with the shader, in which but yeah, the new measure should solve this issue anyway, so I'm not gonna bother much. Let's dive into the new measure. Well, first I want to make sure that this function works, and removing the old code. So the whole thing, this whole thing should be out of the way, and we should only rely on the bottom bit for now. And okay, yeah, I need C, which is a center point, and these others are all the different faces that we find. Let me make a little diagram. So I need a bit more space. I can go on the right. This is our cube. Well, let me use lines this time. I forgot where to find lines. Oh yeah, this is the palette. So here's my cube. My little lovely cube. And I was hoping for something a bit more cubic. So this is our cube, and the faces that I'm looking at, I'm gonna make a little diagram. This is the front, and it's gonna match the F value. So we have the front, we have the up. If this is the front, then this okay, interesting. Not quite sure. So front is going to be y plus 1, and the y is okay, y plus 1 is basically 0, because 0 means that is the one on the envelope side. So, and then plus 2 is the envelope on the next line. But anyway, don't want to waste too much time around. I really need this to work. And why is it mask not being recognized? Blocks is of type of blocks, and that is fine. We have face mask and type. And what's wrong with it? Mask. Okay, maybe it's the type. Oh yeah, it was the type actually. So block type. Oh, it's not the block type. Is it block type? Yeah, block type is fine. And this needs to be casted. Okay. And a static cast should do. And we have block mask. And now the compiler should be happy. Oh yeah, now I remember that at the beginning of the stream I commented that out because it wasn't compiling. You see, quick detour. You always pay them back later. And by the way, I'm planning to make a tutorial out of this once it's in a good state. Let me know if you are interested in what really are you into. That would be great to know what to expect from it. So it can't really be a super beginner thing because Vulkan is not super beginner friendly unless you have some experience with at least a little bit of drawing, because otherwise you're gonna miss a few things, and that's a bit of a shame if you miss like the main concept. And I'm pretty sure like Vulkan, you enjoy it more as you understand why it has been developed, because you really appreciate more the control. It's like yeah, it's like going to a more raw programming language after you've done some higher level stuff and you appreciate the control that you have, but also the risks that it comes with. And I think that's a good thing. Like you really appreciate it more. Okay, I can remove this now because this is working great. The check here is that each so the mask works as a bit field. We have an 8-bit number, an 8-bit variable, and let me pretend these are 8. I'm gonna draw some random lines and pretend there are 8 of them. And I can assign, well, if you know binary coding, and then you know that the numbers are made of a finite number of bits, and depending on the number, we can also encode like binary data in them, and an 8-bit number, you can encode 6 different binary values, and 8 different binary values, and that is enough because our cube only have 6 faces, so that's more than enough. And by the way, what did I do here? 1 2 3 4 5. Oh, oops, that is 5. I need 6 of them, not 5. 1 2 3 4 5 6. Okay, now it's correct. So to have 6 values, that means that if I put a 1 here, which means that this needs to be whatever the coding says. If it says that this needs to be visible because it's in contact with air, then I can put a 1 here. Then if the other ones are not visible because they are covered, then I can put zeros everywhere, maybe except for the top, which deserves a 1. And then this number, I can use the calculator to do some of this reasoning. If you go into the programmer calculator, then you can open the binary the binary number thing, and then you can put in those binary values. So if I put 1, and then it's going to be 0 0 0 and then another 1, so this decimal value is 17, and we can also have a binary value. So you can see that a number can also have a mask inside that is useful. Good luck from Japan students. Hey, laughing man, how are you doing from Japan? Steffi, yo, hi. How are you guys doing? You ready for some meshing? So just for context, whoever's just joining, so today's stream is about bringing more efficiency to our code. So right now the word is running fine because I have a GTX an RTX 4090 here, but the purpose of the project is to run smoothly on what happened? Okay, I messed something. But the purpose of the project is to run on a MetaQuest, so that is definitely demands much more optimization. So I changed something, and all of a sudden I'm getting like all the cubes. Okay, and this is definitely not expected. So we are underground. I think I can just scroll forever, and this is gonna be all ground because we are below the function, and yeah, so it's pointless to just keep going. What did I mess here? So I say that if the block is 0 5, okay, maybe I underestimated. So we need 1 2 3 4 5 So if it's touching that, okay, so 0, yeah, I should have started with 1, because if you do a shift, this is a bit of the bit operator. So shift, for those who don't know, is going to take any value here. Let's say 4. So how is 4 encoded in a binary? Let's say we have our usual things. So 4 is, let's use the calculator. 4 is going to be encoded as a 1 0 0. So 1 0 0 and everything else is 0. A shift operator, it just moves everything to one place on the left, because it's a left operator, turning this into 0 1 0 0 0, which is effectively as multiplying with against 2, and from 4 you can see that will turn into 8, and that's just what it does. It moves things around. So what I'm doing here is that I'm introducing a 1 or a 0, whether the side of the block has something. Oh yeah, I think I have hair in my mouth. Damn it. No, whatever. I'm gonna drink some water. Still there. Anyway. So what happens is that I start with the 1 that is out of the number, and then start shifting it. If I shift it by 0, this is not really gonna move anywhere. So it's never getting into our number. So that is actually, so I'm making an OR. So if it's 0 or 1, yeah, that is actually correct. So we're only gonna use the first 5 places. 1 2 3 4 5 6 places, and that's gonna shift by 5. If it's a 1 and then you shift it by 5, you go to the 5th place, and this is 1 2 3 4 5 and 6. That should be correct somehow. So if it's 6, it means that all the sides are surrounded by other grounds, which should result in this being discarded. I'm gonna break and see what's going on, because it doesn't really make sense. So if this is, well, we have the calculator, so let me try to do some bit shifting around. So let's say we have 1 2 3 4 5 and 6. That should be all six faces, and it looks correct, to be honest. I'm not sure why. So maybe there is something in here. Y plus 2, and then z plus 1, and x plus 1. Yeah, playing around with coordinates is not so fun. So I'm just trying to stop and see what happens during the debug. So we have a mask that is 0. We are probably in the air, and we don't want to be in the air. So maybe I should put a condition here and say that the mask needs to be different than 0. Let's run it again, and it should stop. We haven't computed the mask yet. So let's try again, but after the mask has been computed. Okay. Well, no, that's not okay. Oh, damn it. I need to stop and go check what I have in my mouth. Things all over the place is trying to distract me from getting my job done. So what's going on here? Is this working? Okay, good. And let's try this again. No, wait, I had to check. So if this is not 0, what if it's 0? Yeah, why is it not block stopping? Oh. Yeah, let me remove the condition, and it should stop. And we are starting at 0, 0, 0, which is 0, 0, 0. That's the block. We got a mask of 0. Okay. Okay, I have an idea. I'm going downwards, like very deep. I'm going very deep in the ground. So whenever I get something that it gets generated, it is going to stop. And the mask keep being 0, which is odd. Everything is dirt. So everything is dirt, and this is checking whether this is air. And if this is air, okay, I get it. We're making, bro. Hey, KGO. I'm making a game. So I'm making a game from scratch using no libraries. It's all from scratch using Vulkan and OpenXR, which is the VR standard. And yeah, it's a VR game for the Quest. So hopefully at some point it should work on the Quest. Well, it does work on the Quest. It's just I'm doing an optimization pass. The game itself is just a voxel-based game. Right now, it's just a voxel render. And the problem here that I'm facing is that the generation doesn't match the expectation. And the check that I'm doing here is that if this is air, this is ground. Maybe I should check if this is ground. Yeah, okay. I think the problem here is the direction of the check. So I'm checking if any of this side is air. So if any of this side is air, then this should be that if this is 0, then we are surrounded by ground and the face is not touching any visible air. Since we can only be in air, the player can only be in air or water, but we don't have water right now. So if the block is not touching air, then it's not going to be visible. So this should be the right check to do. And that's going to work, right? I hope it's going to work. And it is working. Yeah, because underneath we don't have a solid block of ground. And that is nice. Okay, the generation is now building correctly. And the new check is also working fine. But in addition to what I was doing before, now I have a map of which of the faces are actually touching which of the faces are actually touching the air. So I can go down here where the polygons are generated and say and check if the specific face is touching air. So this is where the cube faces are generated. And instead of a single array, I'm gonna turn this into append ranges. Maybe I can remove the whole array and yeah, I'm gonna remove this as well, so at least I have a fallback to go back to. And I'm gonna say that indices are going to be pushed range. Maybe I can push a whole range. Yeah, maybe I should add a whole range. Let's see, A, B, and C. Is this going to be a valid C++ code? Let me try to build it, because sometimes the LSP doesn't really get it right. Yeah, you see, I thought that was correct, but it's not. Okay, it doesn't like it. What can I do then? Well, I can make arrays. So working in stack space, that should make it a bit more optimized than having the vectors grow continuously. So at most we can have these faces. Const set array and that will be Okay. We need to check which faces we want to go through. And first of all, we need to check the data mask. Data blocks dot mask face mask, and we need to do a bit masking, and we're gonna check for block mask front. So we're gonna check if the front is valid. If that's front, I need to cast this list number. So that's gonna be a static cast to uint8, which will make it as an official number, and we're gonna make okay, now it doesn't like that either. Why don't you like it? Create non-member operator. So I can create a non-member operator to do that. Create a non-member operator is gonna be let's see what happens here. Is it gonna break everything? It looks like it is generating some useful code. What is the implementation actually? I didn't make me an implementation, but this is this working? So can I just now? No. So something is missing. Where did it generate the code? I've lost where it put the new code. I can find it by filtering. Okay, this is the operator. There is an operator, but where is the definition? Okay, so there is mask and the mask. So the definition is probably something that I have to write. And that is just going to be a static cast into a uint8. Yeah, and this is gonna end into a return. That should be it. And now I can have that very easy, and it should work. So once we have the front mask, the front face that is visible, then we're gonna add this. So we make an array face that's gonna be made of these, and then we should be able to add the face. Okay, let's see if anything compiles now. Well, at least it's compiling, and we should get front faces everywhere. Okay, we're getting front faces. That's nice. And those faces are only visible. Are they visible? They're a bit sus. They don't look like the one that should be visible. Okay. So if there is a 1, let me go back to the definition of the faces here. So this should be 1 if there is air in that direction. And I wonder if I did this correctly. So the direction in here, mask, yeah, this is probably not super correct. The addressing is not correct. So why? Wait, that should be, what did I just use? F. So F is defined as 4. 4 is the third bit, and the third bit, we get the third bit if we shift by 2. So this should be the front, and the front is made of by Y at the center. So this is Y at the center, and then we should move to Z plus 2. Z plus 2 should be in this direction. Hopefully it should be in that direction. And then X plus 1. Yeah, this should be the face that we are looking into. Okay, that should be correct. If it's instead front face plus Z. Okay, maybe that's not the one that I was looking at. Maybe it's the back face that this should be. So if front is not correct, then we maybe want back. Okay, that could be. So I was looking at the wrong place, probably. And now, these are actually the faces that I want to see. Cool, we are moving in the right direction. Now back to the front face. The front face is going to be the back face. Yeah. There's going to be a bit of a repetition here, but we might improve it afterwards. So for the front, we want this. And maybe I will move it down so I can follow the right order in which they are defined. And the top face is going to be the top. That should be easy. It's going to be up, and that's the top face. Mettila. Top face, bottom face is gonna be down. This is the boring part. Copy and paste, copy and paste, copy and paste. But hopefully at the end we should see the light. Even though there is no light, there's no technically any lighting so far. Okay, right face is gonna be plus X, but what did I define for plus X? If front was, what did I define as right? Well, right should be plus X. Yeah, I'm pretty sure this is right, according to Hope. We're almost there. Right and left. Left is the last one. And boom. What a bunch of code. Testing, testing, testing. Is this gonna run? Well, of course it's gonna run. The question is it gonna crash? It is not crashing, which is cool. Is it drawing? Oh, it's not drawing all the hidden faces. Look at that. It's not drawing the hidden faces. That's super cool. So that is actually working. It's a little bit smarter mesher that is doing its job. Now you can go around. Wow. So we have done that by using only a little bit of a change in how the data is defined. But this is still bringing a problem, which is that I'm still defining all the vertices even though they are not used, and that is not useful. So instead of using the indexed rendering, indexed drawing, I should probably step into defining triangles directly in the vertex buffer. And that should be a little bit more wasteful, but on the other hand we should have per face data, or it could even be like both of the worlds, where for each cube that only passes the test. Yeah, let's try this new approach. So only the cubes that pass the test will have a chance to actually have the vertices up in the data, and then we're gonna use relative offset to do the addressing. Okay, following this first optimization, let's stop for a moment and appreciate if this is actually working on the Quest. And if everything is working, we might even commit the changes. So not my phone, but rather the Quest. And start. I'm going to cast the results so you can also see what's going on in the headset. And I feel like this is the old build. Yeah, this is probably the old build. It can't be done already. That would be surprising. No, it's still working. So Gradle is running. It's doing the build. But you already had a sneak peek of what it looks like from the inside. And okay. So the performance are not super great yet. But we already saved quite a bunch of polygons from being rendered. So now I wonder why the performance are not improving enough to be at a solid 120. I guess it's because we are doing too many draw calls, and that might be improved. So let me stop that. And the draw calls, they happen here in the app, in the render function. This is going through all of the elements, all of the chunks, and issuing a draw call. But there are other options to draw the draw call. And let's see, what options do we have? Draw, indexed, indirect. Draw multi-indexed. Draw indexed indirect. Let's see how this works. Draw primitives with indirect parameters and indexed vertices. So that's command buffer, the buffer containing the drawing parameters. Okay, so we have a bunch of parameters that we need to allocate. Command draw index behaves similar to draw indexed, except that the parameters are ready by the device from a buffer during execution. Okay, I get that. So we just need to create the buffer. That's a long list of That's a very long list of rules. Okay, well, maybe I'm not even sure that indexed is the one that I would like to use at this point. Let me first explore the non-indexed version. Or let's do further optimization before going into bulking the automating the render call, the draw calls. I'm gonna start from here, and instead of using indices, well, we can also use indices, but these two loops are going through the same values. So instead of using indices, then we can say that A, B, C, D, E, F, G, H are vertices, and each of these vertex is gonna reference one of these. Well, actually, instead of instead of doing it like that, I'm gonna create because I like the idea of having them pre-computed in a very easy way, and then I just need to reference them. So instead, I will make a new vector that's going to be std vector of t, which is the vertex type of this structure, and that will be vertices. And I also want to vertices that reserve, and we can simplify this multiplication with the power. And I guess we don't really need to reserve. Well, we can reserve, but we can also not reserve. Okay, so that's about it. Reserve vertices. Okay, so we're gonna have our vertices there. And here, instead of A, B, C, D, so instead of having the direct mapping to the cloud of vertices, I'm gonna make an intermediate. So this is gonna be a vertex A. So these are the V's that index into the main vertices. Then I will m dot vertices. I'm gonna push every vertex into the final array. But first I'm gonna keep an offset of the current elements. So you enter it to off. I can say O. Offset is gonna be m dot vertices dot size. M dot vertices B. Well, I guess so on and so forth. A, B, C, D, E, F, G, and the last one is H. We don't need any more. That's the offset. And here we're gonna have the old ones, but just with the offset. And then copy. That's gonna be V, letter, and O plus O. We add the offset to the current values. What? Wait. Yeah, that is used. What's wrong with it? Local variable can be made const. Okay. Yeah, that's fine. Cool. That's about it, I think. That should be all I need. The code is really bulky, but it should work. It should have fewer indices. Not indices, but fewer vertices around. And especially when it's ship. Holy shit. What is this? No way. By the way, look at the singularity. Why is it even fixed? What is happening? Okay, that was definitely not how I was thinking it would behave. Some of them are working. So what happened here? I'm pushing the vertices that have been generated into the final one and taking the offset. Then I'm adding them. Everything looks fine. Push back V, A, B, C, D, E, F, G, H. Yeah, and this is the vertices. It's got the right number. It's got the right data. And this is the offset. That should be all right. I guess I'll have to debug. I can't see really why it should not work. Wait, what? Is this correct? Yeah, we start with 0, and then after computing the local value. Wait, what? VA no, 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 no. Okay, that's the problem. Yeah. This should have nothing to do with that, and instead it's gonna be a local offset. So that's going to be plus 0 to 1, 0 to whatever, 0, 1, 2, whoops, 2, 3, 4, 5, 6, 7. Okay, this makes sense now. And pretty sure this is gonna work. It must work. All the hopes. But even though it works, yeah, the fact that it's going to be faster is all to be proven. Okay, it is working. And I wonder if the shader is making everything a bit slower, because the frac function is not free. Let's see if that makes any difference. It's not gonna be as nice as it should. Also, I'm still building in debug mode, so that might also be part of the problem. But it's not terribly bad. Let's give it a spin on the device. Look at this beautiful tile. Oh, that's me. Okay, I'm in. The frame rate still below 60, which is not great, but it's a bit more stable now. And yet it didn't pick the change in the shader. I don't know, for some reason I have to build it twice to pick the precompiled shader and Spear V, but that's fine. Okay, so that didn't really make any difference, and I guess the problem here is mostly about the draw calls. So draw calls are probably expensive. And just out of curiosity, let's see if building a release build is gonna make any difference. So that should be not the profile. What's the build type? Structure, service, profile, build variants. Okay. Let's do a release build. It might take a little while. I don't think I've ever tried a release build at this point. That's gonna be a new experience. Man, this thing is heating like crazy. Like I can feel the fan going. Maybe you can feel it. No, I don't think you can hear it, but It's going really fast. And it's heating, like super warm. I should stop. I should stop it so it can cool down a little bit. Okay, so we're just gonna wait at this point. Maybe I can make it a little bigger, these two, even though I'm not gonna use it actively. Just so it makes it a bit more comfortable. Sometimes I get confused and they look very similar. But for some reason, this one is not able to give me a good development experience because it keeps breaking and it's not really good at picking C++20 modules. Is it done? No. Still working hard. I'm gonna get my laptop. Okay. Build was successful. That's already a good step forward. Let's try to run it. So is it done? How long does it take? See, make release build with debug info. Oh, come on, still building. How much does it need to build? And in the meantime, if anyone wants to join me on Discord, I sometimes do hangouts in there. And I'm planning to publish the game as soon as it's kind of playable on the App Lab. If you guys have a headset, and I will be working on multiplayer at some point once I get something working on the rendering side. That's gonna be fun. Oh, he's gonna download the whole world. Yeah, that's what happens when you do the first build. And by the way, you can also grab it from GitHub. GitHub. Not that one. How is it called? So let's go to github.com, AmiGameDev, and Choppy. I haven't put any info yet, but if you open it, then you should be able to grab the project, Android or Windows, depending on which one you want to build. And it's just a regular CMake project, so you shouldn't have any issue. I don't have any Linux, unfortunately, yet, but that should not be a big of a deal. Android, you just have to open it with Android Studio. It's going to download everything from scratch, so that's why it's taking this long, because it's downloading all the required library. But it's done. Okay, cool. That's a good news. And I closed this. I'm gonna reopen the mirror. Is it this one? Oh, that's amazing! It's going 120 FPS. Wait, that means that I can just stop this and rebuild the shader. Give me back my lovely colors. I'm gonna need to build it twice. So build it once. Yeah, I will have to figure this out at some point, because it's kind of annoying. Sometimes you make a change, you don't really remember that you have to build it twice. But this makes me so happy. It means that I can go even harder on the optimization. It is doing great, so it's running at 120 FPS. And I'm pretty sure this was all faults of the fault was mainly on the submission of the draw commands. So it's very smooth. It's loading chunks in and out. I can probably also go a bit more on the distance horizon. I can load in more chunks. The good thing of working in debug mode is that you most likely have a good surprise, which is serendipity. I think that's how you say it. Is it serendipity? Serendipity? Yeah, which is the occurrence of making available as a discovery by accident. Happy accident. Yeah, that's how you would define it. Happy accident, which is how Bob Ross used to always comment his drawings. Okay, so this is pretty good news. I can now push the limits before I will optimize even further. I'm curious to see how far I can push the number of chunks that I can render at a time. And these are generated here. I always forget where they are generated. Size, no, that's not size. Drawing, no, that's not in the drawing. It is close. Okay, generate chunks. Generate chunks. I'm gonna add this to the bookmark. I always look for it and never find it. Okay, so generate chunks. Can I just select what? Okay. Oh, that's nice. When something works as expected, it's so nice. Like, I expected to highlight this, and then when I press F11, it creates a bookmark, but also makes it names it in what I selected. And yeah, kudos to the Sea Lion folks for getting everything right. This is like the best IDE so far. Okay, so the span, the neighbor span, is the number that I want to control, and it's gonna be the number of for each direction, the number of blocks that. So this is the center, and if I say 0, then it's just gonna generate the center point. If I say 1, then it's going to generate all the in every direction one more square or cube in 3D, obviously. So that's gonna be every direction in 3D. And so if I say 2, that is going to be a lot more. Like this is gonna grow much faster than just a single value. And the complete formula is that it's gonna grow n times 2 plus 1. No, n plus 1 times 2. That should be it. N times 2 plus 1. Yes. Cubed. So let me say 10. 10 is going to lead to 10 times 2 plus 1, 21 times 21 times 21. Okay, so this is gonna be 9,000 cubes for every chunk. That's quite a lot. It's quite a lot of cubes. No, it's quite a lot of chunks. And each chunk will have, yeah, that's a lot. Let's see what happens then. That is a lot. And I'm gonna run it on the Quest. Sorry, buddy. You're gonna sweat a lot. You're gonna be sweating. It's still, the fan never stopped. Like this is still blowing really hard. It would be nice if it was winter, but with this, but on the summer it's not great to feel this heat on the hand. Okay, almost there. Installed, but haven't started running yet. How long does it take? Yeah, I know you installed it, but are you running it? It says it's running. I call it BS. Okay, now it is running it. Oh, did it crash? Okay, that's why. It crashed already. And I think it crashed for a reason. Yeah, that was a bit too much. I think it crashed because of lack in uniform buffers, because I only allocated in the shader. So the shader now allocates space for where's the variable? Where's the variable with the number of? Yeah, so 2048, and that is definitely not 2048. What did I say earlier? It's gonna be 9,000. So how much should I allocate? 10,000. Yeah. 10,000. Then 10,000 should be enough, because it's gonna be less than 10,000. I don't expect it to be that high. Meshing is such a pain. Yeah, thanks JK. It's fun though. Like meshing and reasoning about the meshing is that's the more challenging part. But it's also rewarding because once it starts work and you can appreciate the content it just made. I guess the hardest part would be making this multiplayer at some point, and that is where things get a bit more interesting. So I've done graphics programming earlier, but I have never done networking. That's what I'm looking forward. Did it crash again? Yeah, I think it crashed again. Okay, let's lower our expectation a bit. I just want to see it running. and I've say I will never love math enough to build the shaders. Well, I mean, shaders are part of graphic programming. I'm also not too much into shaders. I like more getting the performance, like great performance out of the rendering pipeline. I'm not very much into like making things pretty, as you can see. But I've worked on ray marching, and that is kind of fun. Some point it gets fun, but it's not always fun. Okay, I'm a bit lost. I need to change. What did I say? It was 10. It was 10 somewhere. Okay, 10 is too much. Maybe 5 or 6. Was it 6 at the beginning? I don't even remember. I hope I can find a value that doesn't crash it. And my hand is melting. This thing is crazy hot. Okay. Wait, what's going on? Why is it not running? I think I need to debug this because it's not giving me enough info. I cannot debug this because it's a release build. That's why I'm not getting anything. So it was working fine with 4, but then more than 4 is not working. Let me switch to debug. And then I think I'm done for today. I should start working on the script to make the tutorials. They're going to be a bit shorter than this. This is just the full length development process. But basically, the idea is to break everything down into pieces from the beginning, and there is quite a lot to unpack. Like from this is built from the scratch, like from the ground up, and you can see here that I'm managing the entry point is like bare main. I'm not using any intermediate library. There's no STL of GLFW. I think that is nice to jumpstart, but on the long run, it's just it's just there. Like it's not a big deal to make it from by yourself anyway. creating a window and using it's not that hard. It's just sometimes you get lazy, and that is fine. I'm also planning to make sound at some point, and sound. I've done sound in the past, and that is interesting. It's a field that nobody really likes to get into, so the first library that you find, then it's okay. But sound is kind of a good field to get into, as well as physics. And physics is one of those things that I really want to do from scratch. It's I think for a voxel engine, it's gonna be easier to get started. Like it's not gonna require any crazy physics. So is this working? Okay, we got a crash actually. So that's nice. One could say, why do you say crash is nice? Well, at least I know I have a place to start from, because the worst bugs are the ones that don't leave a trace. And even worse than those are the ones that don't happen consistently. And so they are, I don't know how do you say, they are like, yeah, they keep escaping. Okay, in the render, why is it crashing here? There's a command buffer, vk utils. What is exactly, what is going on? Star model, frame context. Is this oh, weird. I don't really know why this is happening now. So everything looks fine. Is the command buffer even valid? This is a weird value. So it doesn't look like it's valid. Okay. Well, that is disappointing. I'm not even sure why it's happening right now. But I would say that I'm quite happy for the results for today. And I'm gonna say bye-bye to everybody. YouTube's not receiving enough data. Oh, dropped frames. 22 frames dropped. Why did that happen? I don't know. It was during the build, I guess. Well, see you folks. See you to the next stream where we can do something interesting. What is a good topic to go about? Yeah, I would say that trying to switch to the indirect draw call, it's going to be a big gain. So I guess the next step would be to use something like this and see if we can have a good result even in debug. So that being said, see you next time. Subscribe so we will see once more. Bye bye. Have a good day or night.